My dear students, now we are going to learn some formulas of Laplace transformations. Already we have learned the formula that and some properties of the Laplace transformations. The formulas for Laplace transformation that we have learned are the that we have learned L of 1, that is 1 by s, L of e to the power at 1 by s minus a, L of cos of at s by s square plus a square, L of sin of at a by s square plus a square, cos of h at hyperbolic function s by s square minus a square. So difference between trigonometric and hyperbolic is that only this symbol. Okay, so this for this also you can see this symbol. So we have learned these 7 formulas in previous video, and using this formula we have proved. Okay, I have given some hints to prove this, how to derive this formula. So using this formula for trigonometric function, using this formula for hyperbolic functions. Okay, and two and the linear property that we have learned, this is the linear property and the far shifting property. Okay, and after learning this property and the formula, we have done some problems. Okay, so now in this video we are going to learn this 3 formula. Okay, so this formula is called the Laplace transformation of integral of f of t, and this formula is known as Laplace transformation of uh, Laplace transformation of f of t multiplied by t to the power n, and this is division by t formula. Okay, so see this formula, we will not derive this formula here we will just apply this formula. Okay, see what is this. So see, Laplace transformation integral does not mean that we will able to find out Laplace transform of any integral functions. Okay, so there are some restrictions. The restrictions are that the limit should be 0 to t. Okay, if this limit from 0 to t and f of t dt, then this type of functions, for this type of integrals we can find Laplace transformation using this formula. The formula says that it is 1 by s and L of f of t. Okay, so now we are going to apply this formula in some problems. Okay, so see this formula. Okay, using this formula we will solve these problems. Okay, so find out Laplace transformation of 0 to t sin t dt. Okay, so if this is 0 to t, then only we can apply this integral formula. So now see, what is f of t here? This is f of t. Okay, this is f of t. So using this formula, what we can write here? We can write here 1 by s, this comes from this formula, and L of, what is f of t? F of t is sin t. So this is sin t. Okay, so what will be this? And we know the formula for sin t. What was the formula for sin t? See this formula. Okay, now this is the formula for Laplace transform of sin at. Okay, sin at, the formula is L of sin at equal to a by s square plus a square. So what is a here? A is 1. Okay, so using this formula here, what we can write? 1 by s square plus 1 square. Okay, so the answer is s into s square plus 1 square. Okay, this is the one application of this integral Laplace transform integral formula. Okay, so try to understand this formula and apply whenever it is necessary to apply. Okay, so now the next formula is the Laplace transform of multiplication by t. Okay, so next formula we are going to learn Laplace transformation of multiplication by t. Okay, you will be given a function, then that function will be multiplied by some powers of t, and we have to find out the Laplace transformation of that function. Okay, the formula says that the formula is L of t to the power n f of t equal to minus 1 power n d n derivative, this is n derivative d as n L of f of t. Okay, so this is the second formula for today's class. Okay, so now we are going to learn one application of this formula. Okay, so one easy example we will take here. You can see. So one question: find out L of t into sine of t. Okay, so now see what is the power of t here. Power of t is 1. So using this formula, what we can write? So question solution. So see, using this formula, L of t power is 1, sine of t equal to minus 1 whole power 1 d 1, that means first derivative, s to the power 1 L of sine of t. And as we have just learned, what is the L of value of L of sine of t? Okay, so minus d ds L of sine of t. What is a here? A is 1, so 1 by s square plus 1 square. Okay, so the formula for L of sine at is a by s square plus a square. So a is 1, that is why I am writing here 1 by s square plus 1 square. So now take the derivative and what you will get? So here this is minus s square plus 1 whole square, and then s square plus 1 square into 0 minus twice s. Okay, so finally what is your answer? The answer is twice s by s square plus 1 whole square. So till now we have learned two formula. One is this one is Laplace transformation of multiplication by t. Actually it should be t to the power n. T to the power n f of t. The formula is very easy to remember, minus 1 to the power n d n ds to the power n L of f of t. And Laplace transformation of integral is this one. So for particular integral type questions only can solvable using this method. The limit should be 0 to t. Okay, if it is not 0 or it is not t, then we cannot apply this formula. So now we are going to learn the next formula. The next formula is known as Laplace transformation of division by t. Okay, so Laplace transformation of division by t. Okay, what is the formula? The formula is L of 1 by t f of t equal to s to infinity L of f of t dt. Okay, so the third formula of this video. Okay, so one application of this formula, let us do one problem. Question: evaluate L of sine twice t by t. Okay, sine twice t by t. So what is the value of this? Okay, now solution. So using this formula, what we can write? L of sine twice t by t equal to s to infinity L of sine twice t. Okay, this sine twice t, so this is f of t, so sine twice t dt. Okay, so what will be this? S to infinity, it will be 2 by s square plus 2 square ds. Okay, so now what is the integration of this? It will be this 2 comes here, and this is x square plus a square. Okay, the formula is 1 by 2 tan inverse s by 2 s to infinity. Okay, so after simplifying, what you will get? Pi by 2 minus tan inverse s by 2. Okay, so now we have learned three formula. One formula is Laplace transformation of integral. Second one is Laplace transformation of multiplication by t, and the third one is Laplace transformation of division by t. Okay, so now let us do one more problem. Okay, so question: is find out L of, that is Laplace transformation t square e to the power t sine 4t. Okay, so here you can see this function is multiplied by e to the power t and t square. So first we will think that this is one function and it is multiplied by t square. Okay, so for this here we will apply two formula. One is called multiplication by t and the second one is called shifting property, first shifting theorem. Okay, so multiplication by t, what it will give? Solution. Okay, solution L of t square e to the power t sine of 4t equal to, so this is 2. Okay, the formula, so let me write here the formula for multiplication by t is L of t to the power n f of t equal to minus 1 to the power n dn dsn L of f of t. Okay, so this is the formula for multiplication by t formula. And for first shifting theorem, what was the first shifting theorem? If this is one formula we have to apply, and the next one is if L of f of t equal to f of s, then L of e to the power at f of t equal to f of s minus a. So one, this is called shifting theorem and this is called multiplication by t formula. These two formula we will apply here. Okay, so now see here. So we are going to use this formula first. Okay, we are going to use this formula first. So what I have to write here? So what is the power of t is? The power of t is 2. Okay, so here see minus 1 whole square d 2 ds 2 L of, so this whole will be f of t. Okay, e to the power t sine of 4t. Okay, so now we are going to apply this formula for in this part. Okay, so to apply this shifting theorem, what is the L of sine 4t we have to know. Okay, so what is the sine L of sine 4t? Sine 4t is 4 by s square plus 4 square. So this is f of s. Okay, f of s. So now it is multiplied by e to the power t. So if it is multiplied by e to the power at, then all s is replaced by s minus a. So here as it is multiplied by e to the power t, that means 1t. So here all s will be replaced by s minus 1. Okay, so now minus 1 to the power square gives plus 1. Okay, so this is double derivative ds square and it will be 4 by s minus 1 whole square plus 4 square. Okay, s minus 1 whole square 4 square. So this is just derivative. Okay, after simplifying this you will get because you have learned how to take derivative, so I will not write all the steps. So after simplifying you will get 3s square minus 6s minus 13 divided by s square minus twice s plus 17 whole cube. Okay, so here what are the formula we have applied? Here you can see first multiplication by t formula, then shifting formula. Okay, then this is the basic formula from the 7th formula. Okay, 7th formula. What are the 7 formula? L of 1 is 1 by s. L of cos of L of e to the power at is 1 by s minus a. L of cos of at equal to s by s square plus a square, and thus so on. Okay, so now using the given 3 formula, try to solve this problem. The first one is t sine twice t, and the answer is given. Okay, t cos of ac. This is the multiplication by t formula. This is also multiplication by t formula. These are okay up to this. Here multiplication by t and first shifting theorem you have to use, and the answer is given. Also try to solve this problem. Okay, these are all multiplication by t formula. Now one question you can ask, how to solve this type of questions. Okay, here sine square 3t, and I have not taught you how to find Laplace transformation of sine square t. Okay, for this you have to convert in sine t. Okay, for example, if it is given cos square twice t, then how to solve that problem. Okay, so let me show some solution of this type of problem. Okay, so you can see this is one that type of problem. Find the Laplace transformation of cos square t. As we have not learned the formula for cos square t, so here see, uh, we can write cos square twice t as 1 by 2 into cos twice t plus 1. Okay, so first make free square in the right hand side. Okay, so now L of cos square t, and using the linear property, what we can see here, L of 1 by 2 L of cos twice t plus L of 1. Okay, so now here L of cos twice t gives s by s square plus 2 square, and L of 1 gives 1 by s. Okay, so now in this way we can calculate the cos square s. Okay, so use this procedure to solve these questions. Okay, so first find out L of this sine square 3t, and then apply the multiplication by t formula. Okay, so again here you can see this is the Laplace transform of integral. Okay, so answer is given this one. So 0 to t e to the power minus twice t sine cube 3t sine cube t dt. So here first what you have to do, first you have to find out apply the Laplace transformation of integral formula. Okay, then inside what you have to write L of this part. Okay, then you have to use you can first use the multiplication by t formula, or you can use the first shifting theorem. Okay, if you use first shifting, I think you have to use first multiplication by t formula, then you have to use first shifting theorem. Then before using first shifting theorem, you have to find out sine cube t. So you have to make this is cube time free. Okay, this is cube sine cube. So first make free this cube. Okay, then find out the Laplace transformation of sine cube t, and then you can apply the remaining formula, that is the multiplication by t, shifting theorem, and integration. Okay, so here up to 12 try to solve all this problem, and if you have any kind of doubt you must ask me. Okay, so now the most important questions here may arise in your mind again, then why we are doing this type of formula, why we are learning this formula, and learning this Laplace transformation. Okay, so now to understand these questions, why we are learning this topic, see this problem. Okay, see this problem carefully. So 0 to infinity t e to the power minus 3t sine t dt. So if you suppose you don't know the Laplace transformation and you are asked to integrate this. Okay, so you can try and try yourself and see how much time it will consume, or how much calculation you have to do to solve these questions. Okay, suppose you don't know the Laplace transformation. Okay, then what happened when you are going to solve this type of problem? Okay, so you may have learned some formula that integration by parts. Okay, that you have to use again. You have to put the limits. Okay, and it may take at least I think 2 to 3 pages to solve this problem. Okay, so now see by using Laplace transformation, how much time or calculations are required. Okay, so now see 0 to infinity t e to the power minus 3t sine t dt. Okay, so now see what we have written here, 0 to infinity t e to the power minus st sine t. Okay, so now see what I have replaced here, 3 is replaced by s. Okay, 3 is replaced by s. Now see e to the power minus st. okay, into t into sin t dt. Okay, so actually what I want to say, so now see here, uh, 0 to infinity t e to the power minus 3t sin t dt, sin t dt. So what I have written here, 0 to infinity e to the power minus st t sin t. Okay, so what I have done here, s is replaced by 3. Okay, so s equal to 3. So now see this whole thing, see what is written here, 0 to infinity, 0 to infinity e to the power minus st e to the power minus st. So f of t dt, so what it can written, it is a definition of Laplace transformation of f of t. So L of f of t is equal to 0 to infinity e to the power minus st f of t dt. So if we have this kind of integral, then immediately we can write L of f of t. So now what is the f of t for this integral? So e to the power st, the inside e to the power st and dt is known as f of t. So what we can write, this is L of this term, okay, t f of t sin t. So now it is the formula for multiplication by t. Okay, so what is the formula for multiplication by t? L of t to the power n f of t equal to minus 1 to the power n dn ds n L of f of t. So this is the formula. So what is power of t here? You can see. So power of t is 1. So minus 1 to the power 1 d, first derivative will be there. So first derivative of L of sin t. So now what is the formula for sin L of sin 80? See here I am writing all formula again and again, but you need not to write all this formula again and again. Okay, so to remember this formula, so I have written many times, L of sin 80 is a by s square plus a square. So what is a here? A is 1, so 1 by s square plus 1 square. So now you know, you have learned how to take derivative. Okay, so it gives s square plus 1 square whole square is twice s. Okay, twice s by s square plus 1 square whole square. Okay, so now we have done integral. Okay, now we will replace this s equal to 3 here. Okay, so now s, if you replace s equal to 3, 2 into 3 square plus 1 square whole square. Okay, that after simplifying, what we have got here, 3 by 15. Okay, now see in this problem, if you are going to do this problem using the general method that you have learned in higher secondary, okay, integration by parts, okay, this type of formula you have learned in first semester or in higher secondary. So you can see, if you do this definite integral using those old formula, then it will consume much time, and it will many calculations will be required to complete this problem. So using Laplace transformation, just you can see 2 to 3 lines we can write this, and we can get the answer 3 by 50. So why we're learning Laplace transformation? So Laplace transformation is applicable to make easier, or applicable to solve the ordinary differential equation, partial differential equation, and some integrals. Okay, so see, don't confuse with the numerical analysis. In numerical analysis, all answers are approximate, but in Laplace transformation, whatever answer we get, those are exact answer. Okay, these are exact answer. Okay, if we do this problem using numerical analysis, then whatever we get here, that will not be exact answer, that will be the approximate. But using Laplace transformation, whatever answer we get, those are exact answer. Also do remember, in numerical analysis, all type of integrals can be solved by numerical methods, or those which are not solvable by calculus method, also solvable by numerical methods. But here in Laplace transformation, some particular types of integrals or some particular types of ordinary differential equations are solvable here. Okay, those are easily solvable. Okay, that saves times. Okay, so listen this video, and the formula we have learned here is three new formula we have learned here. The formulas are, one is called See here, one is called Laplace transformation of integral Laplace transformation of multiplication by t formula and Laplace transformation of division by t formula. These three formula we have learned in this video, and I have uploaded a PDF of this book also, or you can download in from internet. Advanced Engineering Mathematics by S.K. Das. If you type in your internet Advanced Engineering Mathematics in Advanced Engineering Mathematics by S.K. Das, then you can find the PDF. Okay, see from the page number 8, I think 845 or 885, 885. Okay, 885 onwards, you can find Laplace transformation. And today we have learned, I have discussed these three formula and application of this formula. Also, I have discussed why we are learning this Laplace transformation topic. So, if you have any kind of doubt, you must ask me. Thank you.